You melt the ice behind my stone cold eyes. I turn to ashes, but only just sometimes. Inhale your smoke, but you still act surprised. It's not my fault when we end up capsized. You call me crazy now, but you don't understand. I'm calling out.
Everyone, today I am going to discuss with you all the state model construction in state space analysis. Here I write the question as construct the state model of the mechanical system. Here I drawn one mechanical system. In this system we have to derive one state model, or we have to construct one state model. Okay, let's get into the video. In this question, first we have to construct the free body diagram of the first mass component, which is M1. In this question, we have two mass components called M1 and M2. In mass components, all the other components oriented in one or two mass components. So, for constructing the state model, firstly, the first step is to the free body diagram of M1. In M1, firstly, in M1, what are the components connected in M1 and which are they? Firstly, we have the input, which is F of t. F of t is connected to M1, mass component M1, and other K1, K represents the spring and B represents the dashboard component, and the physical variable or the displacement of the mass component M1 is Y1. So in this I drawn one free body diagram like this. Here we have M1 or the free body diagram M1. In this, which is the applied force, that is F of t. F of t be the applied force, I write it as F of t, and the other components oriented in the mass component M1 is the opposing force due to the mass component, which is Fm1, and the opposing force due to the dashboard component, which is Fb1, and the next one is the K1. Okay, F of t, F of t, F of k, F of b1 and F of m1, where F of t is our input and Fm1 is the opposing force due to the mass component, Fb1 is the opposing force due to the dashboard component, and Fk1 is the opposing force due to the spring component, and the displacement of this system, which is y1, or the physical variable connected to the first mass component, is y1. In this, we can write it as according to Newton's law, the applied force is equal to sum of the opposing force. That is, according to Newton's law, I can write it as F of t is equal to Fm1 plus Fb1 plus Fk1. Okay, and this we assign it as, I assign this equation as equation number 1. Then you have to write the opposing forces due to every component and each and every component. Fm1, the opposing force due to the mass component, which is force, which is Fm, which is directly opposing force due to the mass component, which is directly proportional to the displacement of that system. Here the displacement of the physical variable is y, and which is directly proportional to the displacement of that system. And this proportionality constant will be removed by using a constant called m as the mass component m. That is m into d square y by dt square. Here it is, we have m1 into d square y1 by dt square. Clear? D square 1 by dt square. And the next one is Fb1. Fb1 means what? The oppositional force or the opposing force due to the dashboard component. In the case of dashboard, the opposing force which is proportional to the velocity of the system. Velocity is in terms of displacement, velocity is dy by dt, and by removing the proportionality constant we get it as b into the constant used for removing the proportionality, that is b into dy by dt. Yeah, then here we can write it as b1 into d by dt of y1 minus y2. Why it's so called y1 minus y2? Anyone? Big guess. This K1 and B1 is connected in between the two mass component. They are M1 and M2. Okay. K1 and B1 are connected in between the two mass components M1 and M2. We have the displacement of M1 as Y1 and M2 is Y2. Here we choose for the, or here we take the free body diagram of the first component. So I can write it as Y1. Whichever I choose. Which one is I choose the first component, right? So it's y1 minus the next component called y2. If I choose the free body diagram of M2, then I can write it as b1 into y2, b1 into d by dt of y2 minus y1. Here I write it as y1 minus y2 because we take the system free body diagram of M1. Clear? Then the next one is K1, right? K1, that is F K1. K1, K represents the spring component. Then opposing force due to the spring component, which is directly proportional to simply the displacement. Directly proportional to the displacement, and by removing the proportionality, we get it as K into Y. Okay, it's K into Y. Here I can write it as K into, again it's Y1 minus Y2. Why? Because of y1 minus y2, because k1 is connected in between two mass components, they are m1 and m2. Therefore, I choose it as k1 into y1 minus y2. Then I can substitute all these equations in equation number 1. Okay, therefore the equation number 1 changes to f of t is equal to, f of t is equal to m1 into d square y1 by dt square plus b1 into d by dt of y1 minus y2 plus k1 into y1 minus y2. Okay, this is the differential equation d by dt and d square y by dt square. Therefore, it may be therefore, this equation can be defined as the differential equation governing the first free body diagram. Okay, differential equation governing the first free body diagram. And by removing all this, we get it as m1 into, write it as equation number 2. And next, d square y1 by dt square plus b1 into dy1 by dt minus d1 into dy2 by dt plus k1 y1 minus k1 y2. This is equation number 3. Okay, is f of t. This is equation number 3. For constructing the state model, we need only the equation number 3. Okay, equation number 3. Then we want to construct the differential equation governing the second mass component m2. First, you all write this, after which we can go for the next step. Next, the free body diagram of M2. Here we have M2, this is M2. M2 can have 4 components. They are K1, B1, K2, B2 and the opposing force due to the M2 component. So, would write, sorry, M2. In this, no input is, or the no applied force is connected in M2. So we have only the opposing force due to the M2 component. They are FM2, FK2, FB2 and FB1, then FK1. And the displacement of the physical variable connected to the system M2 is Y2. Clear? Y2. So we can write an equation called sum of the opposing force is equal to, here sum of the opposing force is equal to 0 because no input or the applied force is connected to the system M2. Therefore 0 is equal to FM2. First you have to write the mass component. It is the weighted body. So you have to write firstly as the mass component. FM2 plus FK2 plus FB2 plus fk1 plus fb1. This should be the equation number 4, right? 1, 2, 3. This equation number 4. Then we can assign equations like fm2 is equal to m2 into, here it is, m2 into d square y2 by dt square, and for fk2, check k2. K2 is connected to the reference point. Displacement or opposing force due to the spring component, which is directly proportional to the displacement, only to the displacement, the single displacement. That is, the displacement of K2 is y2. Therefore, I can write it as K2 y2, and like that B2 is again connected to the reference point. One of the point is M2 and the other point is connected to the reference point. So we can write it as B2 into dy by dt of y2. Clear? d by dt of y2, because B2 and K2 are connected. One point connected to the mass component, the weighted component, and the next point is connected to the reference point. So we can write it as B2 into d by dt of y2. And in the case of B1 and B2, sorry, in the case of K1 and K2, here I can write if K1 is equal to K1 into y2 minus y1, because again K1 and B1 are connected in between the two mass components. Therefore, we are not able to write it like K1 into y2 or K1 into y1. It's like you have to write it like K1 into y2 minus y1, because it's in between m1 and m2. Okay, then fb1 is equal to b1 into d by, it's directly opposing force due to the dashpot component, which is directly proportional to the velocity. So b1 into d by dt of y2 minus y1, y2 minus y1. Then we can apply all these equations to the equation number 4. Therefore, that 0 is equal to m2 into d square y2 by dt square plus k2 y2 plus b2 into d by dt of y2 plus k1 into y2 minus y1 plus b1 into d by dt of y2 minus y1. This should be our 4, 5. This should be our differential equation governing the second free body component. Okay, differential equation governing the second free body component. Then we have to remove all the brackets and write it like m2 into d square y2 by dt square plus k2 y2 plus b2 d by dt of y2 plus k1 y2 minus k1 y1 plus b1 dy2 by dt minus b1 dy1 by dt. This equation number 6. This is equation number 6. We need only the equation number 3 and equation number 6 to form the state model. You have to write. We'll go for the next step of making the first step or the startup of state model construction is to assign the state variable. Okay, first step is to assign the state variable. For that, we need only the two equations, equation number 3 and equation number 6. Shall we go? Here, we are going to assign the state variables for constructing state model. The state variables are, here we have the physical variables called y1 and y2. Physical variables or the displacements are y1 and y2. And in this, by checking the equation number 3 and equation number 6, we get not only y1 and y2, we have the derivatives of y1 and y2, the first order derivative and the second order derivative also contained in this equation. So we can assign the state variable as y1 x1 is equal. The state variables are x1, x2, x3, x4, like this. It will go. Okay, these are the state variables. So we are going to assign state variables for the physical variables which are given in this question. So in this, I can assign the first state variable for y1 as x1 and the second state variable for y2 as x2. And here, by checking the equation number 3, we have d square y1 by dt square, dy by dt and dy2 by dt. For dy1 by dt, I may take the state variable as x3. Okay, the state variable as x3. And for dy2 by dt, I take it as x4. Okay, x4. In this equation, we have another differential, the second order derivative for y1, which is d square y1 by dt square. We are not able to assign d square y1 by dt square for x5 as dy1 by dt. I assign dy1 by dt as x3. The d square y1 by dt square is definitely the derivative of what? This one, the first order. This is the first order derivative. This is the second order derivative, right? Y1 is the variable. First derivative of y1 is dy1 by dt, and the second order derivative is d square y1 by dt square. In this, dy by dt is x3. I assign dy by dt as x3. Then d square y by dt square, d square y1 by dt square is obviously d by dt of x3. Right? D by dt of x3. So, I am assign this d by dt of x3 as x3 dot. Clear? x3 dot. Here we want to construct the state model like x1 dot, x2 dot, x3 dot and x4 dot. Not x1, x2, x3, x4. x1, x2, x3, x4 are the state variable. State model or the state equation is in the form of x1 dot, x2 dot, x3 dot and x4 dot. Clear? We need the dot points. So here I get x3 dot for d square y1 by dt square. I'll write this above here. I'll write this. Here d square y1 by dt square as x3 dot. Then d square y2 by dt square is obviously x4 dot, but x4 dot is not in this equation number 3. Not x4 dot, d square y2 by dt square is not in this equation number 3. It's in the equation number 6. So I am going to assign all the terms in the above equation. That is for f of t, the applied force f of t, you need to write it as u. Okay. Then equation number 3 changes to u is equal to the f of t, which is u is equal to, for m1 into d square y1 by dt square, I write it as m1 into x3 dot, right? m1 into x3 dot plus b1 into dy1 by dt. dy1 by dt is x3, that is b1 x3. b1 x3. For minus b1 into dy2 by dt is, dy2 by dt is x4. So minus b1 into x4 plus k1 y1 as k1 x1. For y1 I assign the state variable as x1 and for y2 I assign the state variable as x2. So it's minus k1 x2. This is our equation for making state model. In this equation, check this equation, u is equal to m1 into x3 dot plus b1 x3 minus b1 x4 plus k1 x1 minus k1 x2. Okay. I said earlier that our state model construction or the state equation is in the form of x1 dot, x2 dot, x3 dot and x4 dot. Here we have one x3 dot, right? m1 x3 dot. From this equation, we have to find the state variable or the state construction x3 dot. For that, I rearrange this equation as m1 x3 dot is taken in the left side and u minus b1 x3 plus b1 x4 minus k1 x1 plus k1 x2. In this, x3 dot is equal to u by m1 minus b1 by m1 x3 plus b1 by m1 x4 minus k1 by m1 x1 plus k1 by m1 x2, right? We get one of the state equation x3 dot. Okay, then we have to find out the next state equation x4 dot. For that, we are taking the equation number 6. I'll write the state model right here. Okay. I write the equation number 4 as m2 into d square y2 by dt square plus k2 y2 plus b2 into dy2 by dt plus k1 y2 minus k1 y1 plus b1 into dy2 by dt minus b1 into dy1 by dt. Then here we have to substitute all these state variables in equation number 4. We get I'll write it here, d square y2 by dt square is what? Dt square is the derivative or next derivative of dy2 by dt. Here dy2 by dt is x4. Then the second derivative is like d square y2 by dt square is equal to dx by dt. dx by dt we can assign it as x4 dot. So from this equation number 4, I write it as m2 x4 dot. Okay, m2 x4 dot plus k2 x2 plus b2 x4 dy2 by dt is x4 plus k1 y2 is x2 minus k1 x1 plus b1 dy2 by dt is x4 minus b1 x dy2 by dt x3. In this equation, we have to take out the term m2 x4 dot. Okay, taken out the term m2 x4 dot, which is equal to, then again all these tends to negative, minus k2 x2 minus b2 x4 minus k1 x2 plus k1 x1 minus b1 x4 plus b1 x3. In this, x4 dot is equal to minus k2 by m2 x2 minus b2 by m2 x4 minus k1 by m2 x2 plus k1 by m2 x1 minus b1 by m2 x4 plus b1 by m2 x3. Okay, then we got two state equations like x3 dot and x4 dot. The state equation is in the form of x1 dot, x2 dot, x3 dot and x4 dot. For x1 dot, we don't know the values of x1 dot and x2 dot, but we know what x3 dot and x4 dot. So we have to rearrange all these equations and find out what is x1 dot and x2 dot. It's simply, I can say it's simply as, I'll erase all these equations for explaining. Then you have to write all these equations in order of x1, x2, x3, x4. For this, in this term, we have the x1s are, what is the x1? K1 by m2 x1, K1 by m2 x1. Then x2s are minus k1 by m2 x2 and minus k2. So minus of k1 plus k2 by m2 x2, x2. Then what is x3? x3 is plus b1 by m2 x3. Okay, and x4 is minus b2 by m2 x4 and minus b1 by m2 x4. So minus of b1 plus b2 by M2 into X4. Okay, clear? This is X4 dot. Then I rearrange the equation of X3 dot also. K1 by M1 X2 minus K1 by M1 X1. Oh, minus K1 by M1 X1. Then what is X1 X2 plus K1 by M1 X2 and minus B1 by M1 X3 and plus B1 by M1 X4 plus 1 by M into U. We want to find out what is X1 dot and X2 dot. For this, I assign the state variables firstly as Y1 is equal to X1 and Y2 is equal to X2. So, by taking the derivative of y1 and y2, what would we get? It is dy1 by dt, which is equal to d by dt of x1, right? dy1 by dt is equal to dx1 by dt. What is dy1 by dt? We assigned it as x3. Okay, we assign dy1 by dt as x3. So I can write x3. Okay, clear? x3. This x3 is equal to dx1 by dt. dx1 by dt mean the derivative of x1. The derivative of x1 I can write it as x1 dot. Clear? I can write it as x1 dot. That means x3 is equal to x1 dot. So we get the value of x1 dot as x3. Then the next step we have to find, wait. X1 dot is x3. Then the next step we have to find out is what is x2 dot. For this, we assign y2 is equal to x2. By taking the derivative of y2, we get it as dy2 by dt is equal to dx2 by dt. Clear? dx2 by dt. dy2 by dt, what we assigned for dy2 by dt? It's x4. That is x4 is equal to dx2 by dt. We can write it as x2 dot. Okay, write it as x2 dot. That is x1 dot is equal to x3 and x2 dot is equal to x4. So we get all the values of 0, 0. Here it is x3 and here 0, 0, 0. x4 is what? x4. Okay? Okay? All the equations we get. Here we get all the equations. That means we constructed the state model. Then, if you want, you can rearrange it in the form of matrix. That means x1 dot, x2 dot, x3 dot. I'll write. That's the answer. The state equation or the state model, we constructed the state model or the state equation. Then if you want to write the equation in terms of output y1 and y2, you can write it as like we have x1 as y1, the variables y1 is equal to x1 and y2 is equal to x2, right? Then you can write it as y1 and y2 is equal to, for y1 we have 0, 0, 0, 0, 1, 0, 0, 0. But we have the variable x1, x2, x3, x4. This is the output equation of the above system. Clear? Here I go with the state space analysis numerical state model construction. I hope you all can understand. Then thank you.